Hello everyone, welcome to another episode of AP Calculus tutorial presented by premiumtutor. I'm your personal math coach, Tasty. Today in this video, we're going to challenge you guys with this limit question. So let's just get started. For what values of a and b is the following equation true? Well, at the first sight, it might look a little bit weird because as you can see, if we try to plug 0 into the first term, we will get something like sine 0 over 0 cubed. It's basically just 0 over 0. So that means we're having an indeterminate form here, right? Indeterminate form here. So this is the time when we should use L'Hopital's rule to deal with the question. So first, let's set L equals the limit. Okay, so that can make things simpler. Sine 2x over x cubed plus a plus b over x squared. Okay, basically just copy down the question. We're having 3 terms in the parentheses. It's not easy to use, so I'd like to combine them into a single fraction, a big fraction. Okay, so this is going to be our second step. But to combine terms into a big fraction, a single fraction, we need to find their common denominator. To me, I think it's like x cubed. I think x cubed can do. So let's use x cubed. X cubed, and we're having sine 2x. A becomes ax cubed, and b becomes bx, right? The third step would be using L'Hopital's rule, and I'll write this h to indicate that we're using L'Hopital's rule in this step. So let's go. So to use L'Hopital's rule, we simply just differentiate the numerator and then differentiate the denominator separately. You have to be careful that it's not a quotient rule, okay? We're not using the quotient rule here. Okay, so it would become, the numerator becomes 2 cosine 2x plus 3ax squared plus b, and the denominator becomes 3x squared, right? The derivative of x cubed is simply just x squared, 3x squared. So you can see that as x goes to 0, the denominator goes to 0 as well, and the numerator is 2 plus 0 plus b. Since the denominator is 0, so we must have our numerator equal to 0 as well. So it has to be equal to 0. That means b has to equal -2. b has to be equal to -2. So let's plug this result into our expression, into our equation. So limit x still goes to 0, and we are having 2 cosine 2x plus 3ax squared minus 2, and with 3x squared as the denominator. So we're still having an indeterminate form because it's still 0 over 0. So that means we need to apply the L'Hopital's rule again. Okay, so it becomes limit x goes to 0. Okay, the numerator, we need to differentiate the numerator again. So it becomes -4 sine 2x plus 6ax over 6x. But it's still 0 over 0, so indeterminate. So, oh my gosh, we need to use the L'Hopital's rule once again. Oh my gosh, one more time, one more L'Hopital's rule. So many L'Hopital's rule. Okay, it's x goes to 0 still. Well, the numerator now becomes -8 cosine 2x plus 6a over 6 finally. Okay, it's basically, if we plug 0 in, it's basically just -8 plus 6a over 6. This is equal to 0. So the only possible situation is that the numerator itself is 0, so it's -8 plus 6a equals 0. So a has to be equal to 8 over 6, which is just 4 over 3. Alright, so the answer to this question is a equals 4 over 3, and then we're having b equal to -2. Okay, so that's how you use L'Hopital's rule to solve this kind of question involving indeterminate forms. Okay, I hope you find this video helpful, and if you have any question, just contact us. You can leave a message, you can send an email, contact us on Facebook or Line, and I'll see you in the next video. Bye.